Find the domain and range of the three functions given here. So part A first, it's a quadratic, so the domain is going to be all real numbers. For the range, we need to find the vertex. Now for this one, I'm going to complete the square. So I'm going to write it as x minus 2 all squared. I need to then take away minus 2 squared, which is 4. And then I've got the add the 2 on the end. So I've got x minus 2 squared minus 2, which means the vertex is at 2 minus 2. So the range is going to be all values of y such now that, given this is a positive quadratic, it's all values of y greater than or equal to negative 2, because it's a positive quadratic, so it's going to look like this. That's everything above that. For B, again, it is a quadratic, so the domain is all values of x, such that x is a real number. It's already in completed square form, in vertex form, so we know the vertex is at minus 2, minus 3, which means the range is going to be all values of y, such that, now this time it is a downwards facing, a concave down quadratic, going through something like this. So it's going to be all values below that y value, so it's y is less than or equal to negative 3. Part C, it is again a quadratic, so the domain is going to be x such that x is a real number, all real numbers. Now for this time to find the vertex, I'm not going to complete the square. This time I'm going to use the axis of symmetry. So the axis of symmetry is x equals minus b, which is 6, over 2a, which is going to be minus 6. So we're going to get 1. And so that's the x coordinate of the vertex. So the y coordinate of the vertex is substitute 1 into the original function, is minus 3 plus 6 is 3, minus 1 is 2. That means my vertex is going to be at 1, 2. This is the concave down, so it's going to be showing something like this. And because it's concave down, I want the values below. So the range is going to be all values of y such that y is less than or equal to 2. I could have completed the square on this one to find the vertex, and I could have used the axis of symmetry to find the vertex here. I chose to do it this way around because I think when you've got no, the coefficient of x squared is 1, I think it's quicker to complete the square than to do this method because it's more direct. But when the coefficient of x squared is not 1, I think this method is less likely to lead to mistakes. I think people tend to make mistakes completing the square when there's a non-1 coefficient of x squared. So this is probably a bit safer. If you're very happy completing the square, you can do completing the square here. What really matters, as I said, is you got to find the vertex. It doesn't particularly matter how you get there. You just need to find the vertex so you can find the range.